Hello everyone, welcome to my channel ECE Scholastic. I am Jasmine. In today's session we are going to see a wonderful topic called signal flow graph. So we are going to learn what is a signal flow graph, what are the basic elements and terms, and what is the symbolic representation of each element. Let's start the session with the first topic, that is signal flow graph. So signal flow graph is a graphical representation of a system. In the previous session we have seen about block diagram, where block diagram is called as the pictorial representation of the system and signal flow graph is called as the graphical representation of the system. So this signal flow graph was developed by S.J. Mason. We are using this system to represent a system with linear algebraic equations. Okay. The output of signal flow graph and block diagram are the same. That is, we will be finding what is the overall gain or overall transfer function for the given system. So when we are following the SFG method and when we are following the block diagram technique, we will be getting the same output, but the only difference is block diagram reduction is a complex technique, whereas signal flow graph is the easiest technique and we will be having a less computational time. Okay. Next, let's see what are the basic elements and terms. So the basic elements and terms can be categorized as node, branch, path, transmittance and loop. So among these five, node, branch and path are the basic elements, whereas we can consider this transmittance and loop as the terms of SFG. Okay, we will be seeing one by one in detail. So first is called as node. A node is used to represent a variable or a signal. That is, we can say whether we are going to represent an input node or output node, which can be represented with the help of this node. Next is branch. So a branch is the directed line segment joining two nodes. So if I am considering this as one node and this as one node, if I am connecting these two nodes with the help of a directed line segment, we can call this as a branch. Okay. Next is path. So what is a path? Traversal of connected branches. So this is one branch. I am considering another branch. I am considering another branch. So a traversal of connected branches with arrows is called as the path. Okay. Next is transmittance. Transmittance is called as the gain of the signal when travels from one node to the another node. So this is node 1 and this is node 2. When the signal travels from first node to second node, the gain it takes as G1. G1 is called as the transmittance. Okay. Next is the loop. Loop in the sense, if I am considering 1 as the node, I am traveling to node 2 and again I will come back to node 1. So this forms a closed path. So a closed path is called as the loop. Okay. Now let's discuss what are all the terms that comes under each elements. So under node we will be having three, that is input node, output node and mixed node. The other name of input node is source and the other name of output node is sink. Similarly under path we are having open path, closed path and forward path. Similarly under loop we will be having individual loop and non-touching loop. So let's see one by one. First is input. Input node is a node that contains only outgrowing branches. So I am considering this as input node. It has only outgoing branches. Okay. So what will be our output node? It has only incoming branches. So if I consider this node, I can say it has the incoming branch. Correct. So output node is a node that has incoming branches. So what will be a mixed node? It is a combination of input node and output node. So if I consider this node, I have both incoming and outgoing branches. Correct. So I can say it as a mixed node. So second node I can call it as a mixed node. So next is open path. So open path is a path. It starts from one node and ends at the other node. Okay. It will be a closed path. The starting point and the ending point are the same. Then it is called as a closed path. So what is a forward path? Forward path in the sense the signal flows from the input node and it reaches the output node without crossing any other loops. Okay, without crossing any other loops, then it is called as a forward path. Next is loop. So under loop the first category is individual loop. So we can say individual loop is a loop that starts from one node. After passing through a certain path, it reaches the same node. Same to us this, which is non-touching loop. So if we are having more than two loops in a system, see I am considering this as node 3 and this as node 4. Here also I am having a loop. Okay, so if I consider these two loops in the given system, I can say the nodes connected to first loop is 1 and 2 and the nodes connected to the second loop is 3 and 4. So there is no common node between these two. Correct. So we can say these two are called as non-touching loops. That is, the loop without common node is called as non-touching loop. Okay. So let's see the symbolic representation. So here node 1 is called as the input node. Why? Because this is the node we are having an outgoing branch. Correct. Similarly, node 5 is called as the output node. Why? Because output node is a node that has incoming branches. Correct. Now we can say 2 and 3 as mixed nodes. It has both incoming and outgoing branches. Okay. Now if you see this clearly, that is node 2 to 3 and node 4 to 5. If you see this, from 2 to 3, 3 back to 2. So it forms a loop. Correct. Similarly, from 4 to 5 and 5 back to 4, it also forms a loop. So we can say these two as loop, or in other words, we can say the starting point and the ending point of the loop are the same. So we can say it as a closed loop. And also the nodes related to the first loop is 2, 3. The nodes related to the second loop is 4, 5. There is no common node between them. So we can say these two as individual loops. Okay. Now let's consider the next one, that is gain. Gain is nothing but transmittance. So from 1 to 2 we have a gain as G1, from 2 to 3 we have gain as G2, from 3 to 2 we have a gain as minus H1. So the gain that is present when the signal passes from one node to the other node is called as the transmittance. Okay. Next is, if you see from 1 to 5, we have a path. That is from 1 to 2, 2 to 3, 3 to 4 and 4 to 5. So it forms a path in the forward direction. Correct? Which is called as the forward path. Okay. About the symbolic representation of the signal flow graph. So if you have any queries related to this, please mail me. Thank you. Thank you for the patience. Don't forget to like, share and subscribe.